Just think about it for a second. Right now, you're walking, maybe talking, thinking, perhaps even dreaming later tonight. And inside your head, you've got this living history book, billions of years recorded in tissue. Every single thought you have, every emotion, every step you take, it's all built on these layers of evolutionary genius, really, put down over these huge sweeps of time. It's genuinely mind-blowing. Okay, let's unpack this a bit. Today, we're doing a deep dive into, honestly, one of the most profound stories in biology. It's the epic saga of how the human brain actually came to be. And look, this isn't some story about a sudden creation moment. No, it's all about relentless adaptation. It's layer upon layer added by, natural selection. So our mission here is to pull out the really key insights from the sources, give you a shortcut, basically, to understanding this living museum you carry around in your skull.
Yeah, and what's really fascinating, I think, is how those ancient foundations, first layers, they still shape so much of what we do and think today. Our modern thoughts, our behaviors. It's way more pervasive than we tend to realize. It shows how evolution doesn't just scrap everything and start over, right? It builds on what works, function first.
Absolutely. That deep evolutionary inertia you called it. What worked back then? Well, it's still humming away now. Okay, so let's go way back. Right back to the beginning, what some sources call the primal spark. We're talking billions of years ago. The first organisms, their brains, if you can even call them that, were basically just clusters of cells that reacted. Wired for one thing. Keep going. Persist. Existence then was just this constant, brutal negotiation, wasn't it? Find food, don't be food, reproduce. That's it. And right there, at the very bottom of what eventually becomes our brain, is the brainstem, the oldest part. Think about what it did, what it still does for you right now. Imagine like an early fish or maybe a reptile. Its survival hung on automatic stuff. Heart beating, breathing in and out, that instant reflex, jump away from a shadow, snap at something edible. The brainstem was the original bodyguard, just keeping the lights on, managing those vital life support systems. It wasn't about thinking, it was about just being. The autonomic nervous system, basically. All that stuff happening without you consciously doing a thing.
And that brings up a really interesting question, doesn't it? If it's so basic, so ancient, why is it still there? Why is it so protected, so deep inside, even when we develop brains capable of, philosophy or planning trips to Mars? What does that tell us about what any living system absolutely needs? Because think about it, even the most logical person, right? They can't just decide not to have that fight or flight response kick in when, bang, something dangerous happens.
Yeah, that's
your brainstem just takes over. Survival first. That shot of adrenaline. That's your ancient brainstem saying, pay attention now.
Yeah, that's such a crucial point. It's not just survival. It's the priority of survival over everything else. Even our conscious thoughts sometimes. So it was, okay, the brainstem nailed being. But just existing apparently wasn't quite enough as things got more complicated. Creatures needed to do more, move better, which leads us to the next layer. Life gets complex. You need to navigate tricky terrain. You need to hunt better, escape faster. A simple twitch isn't going to cut it anymore. You need precision, balance, rhythm. And this pressure, it pushed the evolution to the next layer up, the cerebellum. Right? The cerebellum, often called the little brain. It became this sort of unsung hero for coordinating movement. Imagine some four-legged ancestor learning to run, like really fast over bumpy ground, not tripping. Or think of a primate swinging through trees. That amazing accuracy, it's almost like ballet. The cerebellum wasn't deciding to move necessarily. Other parts handled that, but it was making the movement perfect. It's like this incredible motor learning machine, always fine-tuning muscle contractions, joint angles, using feedback, predicting what needs to happen next to keep things smooth and balanced. Without it, every step is a stumble. Every leap misses.
Exactly. It's constantly running these complex calculations, these internal models, predicting sensory consequences of movement. It's why things like riding a bike or even typing become automatic, second nature. Your cerebellum takes over, freeing up your conscious mind.
Yeah, you don't have to think about every single finger movement when you type fast.
Precisely. And connecting that to the bigger picture. It's really something how the need for just physical agility drove the evolution of such a sophisticated piece of neural hardware.
Yeah.
And it's still doing that job today, refining our most complex modern skills. Playing a violin, the subtle finger movements, the bowing, or typing like lightning without looking. What incredible algorithms did evolution stumble upon there?
It's amazing.
It's not just practice makes perfect. It's the brain learning to anticipate, to correct tiny errors almost before they happen. That smooth flow you see in a great athlete or dancer. That's the cerebellum conducting this beautiful, intricate symphony of muscles. Master of precision, predicting, executing, constantly.
It really is stunning how basic physical needs shape so much brain architecture. But okay, so creatures are existing, they're moving well. But then something else started happening. They began navigating not just landscapes, but social worlds. This marks a really pivotal shift, I think. Creatures start living in groups. Parents start caring for young for longer periods. The world isn't just threats. There are rewards, too. Friends, maybe. Safety in numbers. So basic survival instincts and smooth moves weren't the whole picture anymore. You needed memory, who's friend, who's foe, where's the good food spot. You needed a sense of belonging. You needed those powerful driving forces, emotions, fear, sure, but also pleasure, attachment. This is where we see the rise of what people often call the mammalian brain, specifically the limbic system. These subcortical regions really blossomed in early mammals. Yeah, the limbic system. These areas became the kind of architects of our deepest feelings and drives. Think about a mother mammal, that intense bond with her cub, risking yourself for it. That's not just logic, that's deep wiring. Or maybe an early human feeling that huge wave of relief finding shelter and connection after being chased. These parts of the brain, fueled by chemicals like dopamine for reward, serotonin for mood, they wired us for fear, yes, to avoid danger, but also for pleasure, seek out food, mates, and crucially, attachment. Social bonds became vital for survival in groups, and they started laying down memories, but not just facts, emotionally charged memories. Learning from experience got way more powerful. This place feels dangerous. This food tastes amazing. Tagged with emotions. Why we form such strong bonds, right? Family, community, it's that ancient echo.
Absolutely. And what's just wild is how ancient these parts are, but they still dictate so much of our modern lives. Passion, love, loyalty, but also prejudice, irrational fears, anxieties. So how do these really primal emotional circuits, forged in a world that was purely about survival, how do they mesh with today's world?
Yeah.
With complex ethics, abstract concepts of justice or art?
That's $1 million question.
Is our deep need for connection just that echo of old survival tactics playing out? I'd argue it is that ancient strategy, but manifesting in incredibly complex ways now. That gut feeling you get, that immediate like or dislike, that's often your limbic system firing off way before your thinking brain catches up. Sometimes helpful, sometimes not so much in our complex world.
Yeah, that tension is something we all feel, I think. Okay, so for millions of years, the world is run by creatures with instincts, refined movements, strong emotions. But then something really extraordinary starts happening. An evolutionary gamble, you could call it. The massive expansion of the cerebral cortex.
Yeah.
And it was a gamble, right? Because this new brain tissue is incredibly expensive to run. It needs tons of energy, a big cost for early humans.
Huge metabolic cost, yeah.
But the pressure was building. Ancestors facing more complex environments, starting to use tools more effectively, mastering fire, living in bigger, more complicated social groups. The need for abstract thought, for better communication, for planning ahead, it just became immense. That seems to be the tipping point. And the cerebral cortex, especially that wrinkly outer layer, the neocortex that was the canvas for all these new tricks, symbolic thought emerged. Language, not just warning cries, but complex ideas, stories, the ability to imagine different futures, plan for them, and crucially, learning not just from your own experience, but from the accumulated wisdom of others, passed down. Thanks to neuroplasticity, the brain's ability to rewire itself.
That plasticity is key.
It really was the leap from just reacting to reflecting, from just living to understanding living. You can picture it, right? Early humans around a fire, maybe sharing stories, planning a hunt for next week, figuring out how to make a bitter stone axe. That's the cortex making it possible, turning experience into knowledge.
And this is where it gets really interesting. I mean, profoundly human. This part of the brain, the cortex, lets us do things like compose symphonies, right? Explore distant galaxies with telescopes, ponder our own place in the universe. But it's actually, in evolutionary time, a pretty recent upgrade. So how did the skills needed to plan a group hunt, say, transform into the ability to write a novel or build a global financial system?
So it's an incredible jump.
It seems to be about the underlying cognitive tools getting refined and repurposed. Foresight, complex problem solving, abstract thinking, representing things symbolically, and of course that incredibly flexible language capacity. But what specific pressures drove that explosion, making us capable of such incredible creativity and compassion, but also, let's be honest, stunning cruelty and destruction? It suggests, doesn't it, that our evolutionary journey isn't finished.
Not by a long shot.
And maybe the most exciting thought, what else could emerge from this amazing structure? What new capacities might still be waiting to unfurl within those intricate folds? What new levels of understanding are possible as our brains keep adapting? We can barely imagine.
So, okay, bringing it all together. What does this journey through brain evolution mean for you listening right now? Just take a moment. Consider those layers inside your own head. You're carrying that ancient, relentless drive of the brainstem. the smooth, practiced grace of the cerebellum, the deep, powerful emotional currents of the limbic system, and the limitless curiosity and planning power of the cerebral cortex, all working together, or sometimes maybe arguing a bit. You are quite literally a walking, thinking archive of billions of years of life's incredible journey.
Exactly. And maybe think about this. When you feel that flash of fear, that automatic reaction, or maybe a sudden craving, how does knowing it's an echo from a deep, ancient survival program change how you see it or feel about it? What does it really mean to be a creature built up from these different stages? You can have a gut-level panic, totally instinctual, and then 5 minutes later be calmly working through a complex scientific problem or appreciating a piece of music. It's quite the mix.
It really is.
So as you go about your day, dealing with modern life, do you notice that interplay sometimes? The pull between the older parts and the newer parts, that snap judgment versus the more considered, reasoned thought. And what could that friction, that internal conversation, tell us about the evolution that's still happening, silently, inside us, with every choice we make?
Your brain isn't just this static organ you have. It's a living museum, yes, but a dynamic one, a testament to the incredible, relentless power of evolution. Still adapting, still changing, still writing its next chapter. And you're living it, which is maybe the most profound thought of all.